bedside, that means from when we make a discovery, a fundamental discovery of how cancer cells are different or some feature of one subset of cancer, that we take those discoveries and try to build them up to the point that we can actually have a specific therapeutic based on our discovery that enters into the clinic. And it'll just start off in an early stage clinical trial. That's great. That has been the goal of all researchers for the past 20 years. We basically have enough information now that we know that that is not good enough. We can just safely assume that even in those early stage clinical trials, that there's critical information that comes out, that only a subset of patients are likely to respond, even to the most thoughtful and rational scientific approach. So what we need to do now is to actually take the data right out of those even early stage clinical trials, come back to the bench and figure out what are biomarkers, what are the specific things that are in common amongst the exceptional responders to a new therapeutic, and what is in common amongst the people who don't respond at all, as if they've been given placebo. So that is a major feature of our approach and of our goals for the future. We also want to, as you heard, we want to shorten the time that it takes, even from an initial discovery, to get into the clinic in the first place. This used to take, until very recently, on average, about 15 years. We want to chop that down to more like 3 to 5 years, we think is possible. So that is a very active goal that we have to try to meet. And then finally, here at Salk, again, one of our key focuses is on that interface of research disciplines. We know that by having a card-carrying cancer biologist sitting right next to a neurobiologist, sitting next to someone who works on the immune system, that new ideas will percolate and come out that don't come out in other places where there's a whole building dedicated for immunology. And then there's a separate building dedicated for solid tumors and that type of thing. Salk is really very unique in that way. So what are the key things that make Salk different? Contrasting with what I just told you about other major cancer centers where there's 8 10-story glass buildings dedicated to different subtypes of cancer, Salk is small. But it is also small by design. Over the years, over the past couple of decades, there have been many calls and offers from corporations and individuals to build other buildings around us, to build campuses in other places. And the faculty have always thoughtfully considered those and always ultimately decided to not pursue that, because we actually believe that one of the secrets of the many breakthroughs that consistently come up here is because it is still confined to the original 4 walls, the original Louis Kahn-inspired building, which also, for those of you who haven't toured at Endless Times, is all open laboratory space. And that was what Jonas Salk originally wanted when he worked with Louis Kahn. He wanted people to intermix. You may also have noticed there's no room numbers even. This is very challenging for people when they first start working here. Baffling and frustrating, I'll say. But that also, Jonas wanted that. He actually wanted people to physically bump into each other and ideas to bump into each other. And I think the proof is already in that that worked and continues to work. And so we want to keep it that way. Another thing that goes back to Jonas's original vision for the place is bold thinking. Really to think of what are the biggest, most vexing, challenging problems in a particular disease. So rather than making a series of safe, incremental advances, I'm going to study this small subtype of lung cancer and then maybe in a couple years branch out to the other one, to step back. And we really encouraged our young faculty when they start here to think of that. What are the broadest unanswered questions? How does metabolism work with the immune system within the immune cells and the entire surrounding environment to reprogram cancer? Big, broad questions. So not, a series of quick first downs, but actually, Hail Marys. Go back, kid, all the way back. That also brings vexing challenges, but we believe that that's how real breakthroughs happen. And finally, another feature that helps make the other 2 possible is because the place is so collaborative. It's really in the DNA of the place and in the individuals that first came and then carried on the history that Jonas and the original faculty fellows created. This picture is a picture of all of the current professors and senior staff in Salk's Cancer Center, as well as a handful of people on our external advisory board in the front row. And this shows you exactly what I mean when I say that it's small, and exactly what the size and the faces of the people who are working hard every single day, right now, to fight cancer at the Salk. But we don't, as I said, just do that alone. In fact, we engage with other partners both locally as well as internationally, nationally and internationally. So some of you may not know this. In the United States, there are actually only 2 cities in the whole U.S. that have 3 NCI-designated cancer centers. One of them is New York City. I don't just mean Manhattan, like all of New York City. The other is San Diego. You're sitting in one of them right now, and the other 2 are within 2 miles of where you're sitting right now. So the UCSD Moores Comprehensive Cancer Center is one of the others in San Diego, and Sanford Burnham has another so-called basic cancer center, like Salk's, and slightly different than New York. Here in San Diego, all of the research, the cancer centers work together in concert. We're not competing with each other for patients, for anything else. And that has allowed us to really leverage things in a greater way than would have been possible. It's just one example of that. We actually have joint fundraisers, including the Padres Pedal the Cause, that probably even some of you in the audience take part in. And this has been a major boost to even the research here at Salk, because we have now started working routinely with clinicians at Moores, writing grants together, working on individual patients in real time. So there are examples of patients at Moores right now and at Rady's Children's Hospital right now, and samples are coming back across the street, and researchers here at Salk are working on them in people who are still alive. We're coming up with things based on what is going on in real time. And that simply was not the case, and probably was not even possible even 5 years ago. So this is truly a unique time in the world of cancer research, but it's also a very unique time here at Salk. I just want to mention one other thing that's on the slide here. Some of you will have heard of Stand Up to Cancer. That's the Hollywood-based, George Clooney, Jennifer Aniston telethon that happens once a year, that it is very prominent in funding different types of cancer research. They deliberately fund teams that cut across different cities, even cut across cities internationally. We're very proud here at Salk that of the current 10, there's only 10 total active DREAM teams funded by Stand Up to Cancer, and we have one of them. That's headed by Dr. Ron Evans, who you'll hear as part of our panel, working with Dr. Tony Hunter and Jeff Wall, with a team in London, in fact, for fighting pancreatic cancer. And I'll just leave it at that, but that's another amazing thing that we have going on. In the last 2 slides here, a little flavor of what I mean by discovery beyond boundaries. So for those of you who don't know a little bit more about that fundamental discovery, in the late 1970s, about 500 yards from where we're sitting right now, Tony Hunter made a discovery about a protein modification. He discovered a new, unexpected protein modification. Many people may have noticed what he saw and literally thought, that's weird, I don't know what that means, I'm going to ignore that and get back to what the point of the experiment was, because that was not the point of the experiment. But Tony, not being not thinking in that way, thought, this makes no sense, this is heretical, and I'm going to chase this. And chase it he did. And he nailed down this new discovery, but he didn't stop there. So if that first observation was true, then, and it was enriched in cancer cells, and the prediction would be whatever's causing it might also be enriched in cancer cells, and maybe it would be a drug target. So first, they had to find the enzymes that were causing the modification, and he and others did that. And then after that, it took another 20 years to go from the original observation until there were actually small molecules that could work in people, survive in the blood, hit the target in the tumor, and actually then get FDA approval. And Gleevec is one of the first examples of that. It was first approved on a limited basis in 2001. Tony made the discovery of tyrosine phosphorylation in 1979. So that tells you a little bit about what the course of how things have happened in the past. Now, since 2001, there are 32 tyrosine kinase inhibitors that are widely used in all different forms of cancer, and there's probably another 30 more than that behind them already actively in trials. This is the kind of transformative discovery beyond boundaries that the Salk is famous for, and we want to do more and more of in the future. And it's hardly the only one. Another example that I'll just touch on, because you'll hear more about it from Dr. Evans himself on the panel. But in the past 5 years, Ron Evans' lab, who's a leader in exercise and in metabolism and metabolic disease, Ron's lab has worked on cancer in the past, as he'll tell you. But he now started getting interested in pancreatic cancer. And of all things, it stemmed out of an interest in fibrosis in the liver. Not actually in cancer, but actually in studying a particular vitamin that actually regulates whether or not your liver undergoes fibrosis. What he also knew was that one thing that was becoming apparent more and more when people were studying pancreatic cancer is it wasn't just that there weren't good drugs, which there's not, but on top of that, the drugs they did have weren't even getting inside the tumor. So you couldn't even begin to make a good drug because you couldn't get anything to get inside the tumor in the first place. And Ron wondered, well, is there a way that we can actually use the information we gained from fibrosis and study the pancreas and unlock the secrets of pancreatic cancer? And I'll stop there and let Ron tell you the rest of the story. Finally, to come back to Dan's intro of me, my own discovery about 10 years ago now, of this direct connection between a commonly mutated gene in lung cancer and a central metabolic enzyme involved in fighting type 2 diabetes was also completely heretical. And the people who worked on cancer absolutely hated this idea. And the only people who hated it more than the cancer people were the people who worked on type 2 diabetes, who completely despised the idea that there might be something so direct and causal. From that point, though, we thought if that's true, that this anti-diabetic drug, metformin, which is the most widely used type 2 diabetes drug in the world, if that actually has anti-cancer properties, then another prediction that comes out of that is that not only will all the people who've been taking metformin actually have a lower risk of cancer, which turns out to be borne out, but beyond that, that the whole pathway around it, all these other metabolic enzymes, might be deregulated in different subsets of cancer. So that has been a passion of mine and my team, working with Ron Evans, also now working with Sue Keck in the immune system, and they've done brilliant, orthogonal approaches, which has now opened up whole new areas. And it's that same type of just unexpected doors then open to other doors, and it turns out you're in the middle of a labyrinth and you didn't even know there was a door in the first place. Okay. So let me just wrap up then and say the take-homes you should walk away with are the Salk is small, nimble, and innovative. And we believe and we know that for the first time, things that were previously deemed untreatable are in fact treatable. And the message I want to send to all of you is really to join us as we set out to conquer cancer.
This